Welcome back, guys. This is the second video of the series Important Laws of Physics. Yesterday we talked about Newton's law, Pascal's law. Today we shall see some more laws like Kepler's law of planetary motion, Faraday's law, Archimedes principle, and many more. So before proceeding to today's law, let's take a quick look at the previous laws. So previously we talked about Newton's first law. Everybody remains in a state of rest or of uniform motion along a straight line unless and until it is compelled by an external force. So if you want a detailed summary of Newton's first law, I will give you the link, and in the description you could see the video from there. Okay, so now let's proceed to the next. Second law: when an force acts on the body, the momentum of the body changes. Larger the force, greater will the change in momentum. This is summarized in Newton's second law of motion. The rate of change of momentum of a body is directly proportional to the net force acting on it and takes place in the direction of the force. I told you earlier, if you want the complete detailed summary, then you may see my previous video. I will give the link in the description. Go and see from there. Okay, let's move to the third law. For every action there is an equal and opposite reaction. Newton's law of gravitation: the gravitational force of attraction between any two bodies in the universe is directly proportional to the product of their masses and is inversely proportional to the square of distance between them. Pascal's law: transmission of fluid pressure. An increase in pressure at any point inside a fluid at rest is transmitted equally and without any change in all direction to every other point in the liquid. This is known as Pascal's law. This law is useful in designing instruments like Brahma press, hydraulic press, etc. It is principal in development of hydraulic brakes that were used in automobiles. This law is also known as law of transmission of fluid pressure. Okay, so now let's talk on today's topic, Kepler's law of planetary motion. So Kepler was a scientist from Germany. His full name was Johannes Kepler, and he was born on 27 December 1571. Okay, he gave his first two laws in 1609 and the last third law in 1619. Okay, so what was his first law? All planets orbit round the sun in closed elliptical orbits, and the sun is located at the center of it. Okay, so he said that the sun is in the center and all the planets revolve around it. He was one of the person who believed it. In the previous time, many person believed that the earth is in the middle and the sun revolves around it, but Johannes Kepler said no, it is not true. Sun is in the middle and the earth is rotating around it. Okay, so this was summarized in his first law. Now let's move to the second law. A planet revolves around the sun in such a way that the line joining the planet and the sun covers equal distance in equal interval of time. This law is known as law of areas. Let's understand it by a diagram. This is the orbit of a planet. It is the sun. Here is the planet. Okay, so take a imaginary line from the sun to the planet. Area of this will be equal to the area of this. This is formalized in Kepler's second law of planetary motion. Okay, so now let's move to the third law, which is law of orbits. Okay, the square of period of revolution of a planet around the sun is directly proportional to the cube of the average radius of the planet's orbit. This law is also known as law of orbits. Okay, so let it write in the mathematical equation. We get period square is directly proportional to the average radius. Okay, since why average radius is here? Since Kepler said that the earth and other planets revolve around the sun in elliptical orbits, that is why we cannot say that there is a fixed radius. We have to take average radius. Okay, so now let's move to the next, which is Archimedes principle. Okay, so Archimedes principle. What is Archimedes principle? When an body is partially or completely submerged in a fluid at rest, it experiences an upthrust which is equal to the weight of the fluid displaced by it. So now let's understand it. Archimedes said that whenever there is a fluid, example water, take water, and you might have seen that when there, imagine there is a well, okay, and you put the bucket inside the well, and it's going, and when it reaches to the very bottom, and whenever you pull it again to take out the bucket, until the bucket is in the water, you feel like the bucket is not too much here, it is some what do you say, some light, but as you pull it outside, the bucket becomes more heavier. So why does this happen? This happens due to Archimedes principle. No, yeah. So this was for Archimedes said that the way it experiences an upthrust. So here the bucket is experiencing an upthrust which is equal to the weight of fluid displaced by it. Okay. So due to the upthrust, you may feel it easier, but in the air there is no upthrust, so it is difficult to carry the bucket upwards. Okay. So now let's move to the third, Faraday's law. So Faraday's full name was Michael Faraday, and he was an English scientist born in Newington Butts, London, UK. When he was born on 22 September 1791. His law says that the charge on a conductor resides only on its outer surface. He conducted an experiment. We will talk about that experiment later. This was the thing which is used in his experiment. Okay. It looked something like this, and he said that electricity resides only on its sides, not inside any object. Example, take example of a car. Okay, imagine that someone's car is struck in the outside, and it's heavily lightning, and what should he do to prevent getting struck by a lightning? He should close his all the windows, and thus there should be no opening left in the car at any place. So according to Faraday's law, the electrical charge will only reside on it, and since there are rubber tires, the electrical charge wouldn't exist at all after some time. Okay, so now let's proceed to the next, which is Coulomb's law. So Coulomb's law, full name of Coulomb was Charles Augustin de Coulomb. He was a French military engineer who later became a scientist and gave the law. Okay, he was born in Coulomb, France on 14th June 1736. Okay, so he said that the electrostatic force between point charge bodies is directly proportional to the product of magnitude of charge in them and is inversely proportional to the square of distance between them. So this is somehow looking similar to Newton's law of gravitation. Newton also said that the gravitation force between two bodies is directly proportional to the product of their masses and is inversely proportional to the square of distance between them. Okay, Newton also said it, and he is also saying it. So both things are different here. And you know, my friends, that electrostatic force exist in small objects like proton, neutron, and electron. Electrostatic force is present in them, due to which they all are connected. Otherwise, the protons would flow away, neutrons would flow away, and the electron would flow away. So, electrostatic force. Let's take electrostatic force as ES. Es is directly proportional to the product of masses, product of magnitude. Let magnitude be m1 and m2. This is the first according to the first line, and according to the second line, let's write it. According to the second line, electrostatic force Es is directly proportional to is inversely proportional to the square of distance between them. So as I said earlier, this is somehow matching with Newton's law of gravitation. Okay, so this was formalized by Coulomb. So guys, this is up for this video. If you like the video, give it a like. If you do not like the video, please tell me in the comments what are the deficiency. I will try to improve them. Okay, if you haven't subscribed, please subscribe my channel and switch the bell icon to all for being notified by my every video that is coming up. Till then, have a good day and bye. Stay home, stay safe.